Hi everyone, welcome to this video on another chemistry lesson. This one's on chemical and physical changes. This lesson is one that's often taught, and I'm not sure I've ever taught this really well. And thinking about it for the sake of this video, I think the key idea that we want to get across here is the difference between what happens to the bonds. So I think it's helpful to start by drawing out some examples, and you'll see in the slides the way I like to present this is to show kind of examples that look similar but actually are quite different. So a nice example here is the difference between boiling some water in a saucepan and reacting alkali metals with water. So let's take boiling water in a saucepan first. So if I draw a saucepan, something like this, and just sketch that out. And again, I'm starting with the concrete so that students know what I'm talking about. They'll be familiar that if you apply heat, so we can maybe have a flame like this. If you apply heat to your saucepan, well, you're going to get some gas forming up here. And hopefully they're pretty familiar with the idea that this gas that's forming is steam, which is just water vapor. Now what I think is helpful is to then just zoom in on the difference between the water and the steam and kind of show what's happening as a physical change from one state to another. So let's sketch in here, and this is going to be our familiar old diagram, so I'm not going to spend ages on this. The diagram we've drawn lots already with year 7 in the particles and energy scheme, so I'm going to show them all higgledy-piggledy, random arrangement, range of speeds, so on, in random directions as well. They're close together, they're not far apart yet, so there's still some bonds between the particle, but they're quite weak, so they're not in that regular fixed lattice. So this is a liquid, and they should be familiar with that. What is happening in this change of state, which as we'll see is an example of a physical change, if I were to zoom in on here around the steam, what's happening is those particles are now in the gas phase. And again, this will be nothing new, which is why I think it's a nice one to compare to the chemical change that we'll look at in a minute. So we're just going to say, well, actually all that's happened here, well, it's two things really. One, the particles have got more kinetic energy, so they're moving around faster, so I've drawn the arrows a bit longer than they were here. But also, and I suppose this is more important for a change of state, this comes on to kind of thermal physics in year 10 and year 13. What's more important is that actually now the gas particles are far apart. They've overcome these what we've been calling in year 7 bonds between the particles. But the really important word here is between. What's changed here is the bonds between the particles. So I'm going to put this is an example of a physical change, and you can tell students that any change of state is a physical change. So this is a physical change. What changes in a physical change is the bonds between particles. Now again, you may choose not to write this down if you think you've got a group that's going to remember it, because you're going to be asking them to remember this later. But that is the fundamental point, that the particles themselves do not change, it's the bonds between them that change in a physical change. And this is why, as we'll find out later, physical changes tend to be reversible, because if you somehow reduce the energy of those particles, well then those bonds, what we'll later call kind of intermolecular forces or whatever when we get to year 10 bonding, they will be able to reform. So let's look at a similar example, and this is something you can even demo in your classroom. It's always an enjoyable one. Students love it, as I'm sure you know. So if I draw my big water basin here, and I drop some lithium on the top, so I'm going to add some lithium. So I could label these, it might be worth labeling these this time. So this is water, and then I've got some lithium here, like this. Well, what they would see here, they might see the lithium moving about a bit, something like that. So something's clearly happening. But they'd also see some sort of gas forming like this. Now it's always a bit of a tricky one, this, because I think I'm right in saying, chemists may wish to correct me, I think I'm right in saying some of that gas that's formed is actually steam, because there's so much heat generated by the chemical reaction that you do get a bit of evaporation. But actually, the point that we want to illustrate here is that this is there's a different gas being formed here as well because of the chemical change that's taking place. So what I might do here is, again, do a before and after, but it might be helpful to just say, maybe do a word equation first. And again, this is something that they've done in previous lessons, so it shouldn't be too new to them. So if we have lithium plus water, well, what's happening here? And this is where I like to kind of have these three levels, the concrete, the very, very abstract, but then also the micro picture that explains it. So if I zoom in on what's going here, and again, you might want to relate it to the diagram, I'm not going to bother here. But what we've got here is, well, we've got lithium atoms, like this. Maybe I'll do another one here. But we've also got H2O molecules, like this. And again, they should be relatively familiar with these now. So this is an O and an O, H, 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 H. And what's happening inside here, when the lithium and the water are reacting, is the lithium is actually going and joining onto one of the O's, and the H kind of gets left over. This happens again over here, like this, and this H gets left over, gets chucked out. And what we want to emphasize, and you might even want to add a label here, is that this bond and this bond bonds within the molecules, and remember, molecules are really just particles, so bonds within molecules are broken. And again, the language of bonds being broken and formed is a bit it's not always the most rigorous, but for the purposes of year 7 chemistry, I think it helps them visualize what's going on. And the really important word here is within. Where we said in a physical change, that's all to do with bonds between the particles. What we're focused on in a chemical change is the bonds within the particles. And I'm going to write here, this is an example of a chemical change. And what I want to show students is what happens after this. So if this is what happens, well, look, what I end up with is instead of what I had before, which was H2O and Li, actually what I'm going to end up now with is Li bonded to one O and one H still. Li bonded to one O and one H. And it helps that I drew two sets of these, because I can actually show that these two H's bond together. So that's a H and a H, like that. And this tells me what my products are. And again, this is what's nice. And it's also worth emphasizing, I suppose, that actually it's not just new bonds being broken. There's also bonds being formed within the molecules. But again, I want to emphasize that word within. What's changing is the composition of the particles themselves. It's not just the energy between the particles and the bonds between the particles. It's the bonds within the particles. And you might want to complete this story and say that actually, okay, so we've got this one. This is LiOH. Now this breaks our rule. This is not lithium hydrate. So that's one from the last lesson that might catch students out. You're just going to have to tell them that if there's an OH in there, then it's lithium hydroxide. Plus, then we've got hydrogen, this hydrogen molecule here. And again, I think something we forget when we teach chemistry, sometimes we're good at going to this, what are the products going to be, but we forget to relate that back to what's happening at the macro level. And what you want to emphasize to students is, actually, this isn't just steam up here, even though some of it might be steam. It isn't just steam up here. Actually, there's a lot of hydrogen gas in there as well. And hydrogen gas, H2, is what we looked at in the first lesson of this unit, thinking about how it could be combusted with oxygen. So that's a nice way of illustrating the difference between a chemical and a physical change. And just to reiterate, the main point that you want to get across to students here is the difference. Physical change is all to do with bonds between the particles. Chemical change is all to do with bonds within the particles. Now, there's lots and lots of examples in the slides, and then there's kind of two tasks at the end. One of which is just identifying whether a certain change is chemical or physical, and teaching students to look out for some of those clues. And you can talk them through the signs of a chemical change, so color change, temperature change, gas boost, and so on. And then the second part is just a bit of writing, just making some notes on what we've talked about in this section. In the next lesson, it's a much more practically focused lesson, and that's applying these ideas to a very specific reaction, which is between iron and sulfur.